180 meters long, 13,136 gross tons heavy, reaching speeds over 30 knots. This is the story of the longest private super yacht ever built, Azam. Azam uses a steel hull for strength and fatigue life, combined with an aluminum superstructure to help with the process of reducing vertical weight and improving stability. Large yachts often tend to go towards this approach, divide the materials between steel and aluminum in the construction. However, when you have to execute it at 180 meters, then the challenge is tripled. A big problem here was always going to be the thermal expansion. It required very careful management of different types of it, as well as applying galvanic isolation at the joint interfaces. The beam is 20.8 and the draft is 4.3 meters. But it doesn't end here. Just wait until we get to the engines that propel it to speeds of over 30 knots. The exterior of the yacht was designed by Nauta Design, an Italian company. And when talking about Azzam, the co-founder of the company said, Azzam features balanced, modern architecture composed of straight lines and proportional volumes, which are some of the main design principles of Nauta design. So what about the draft and the seakeeping? Keeping the vessel draft around 4.3 to 4.5 meters while still being able to maintain the global stiffness and tank volumes is a work of art. Engineers were forced to push the design toward a long, relatively slender hull for resistance. Of course, it was all but an easy process, which is why they relied on extensive finite element work on girder sizing, bulkhead spacing, and local reinforcement around the water jet intakes. The interesting and quite useful fact about the shallow draft helps reduce squat and allows access to more anchorages, which furthermore aligns with the warm, shallow water brief. In order to meet the 4-meter draft, you cannot have exposed shafts or skegs, another reason as to why the water jets are a much better choice. And let's talk a bit about the maneuvering of this beast. Such lengths and weights require precision and state-of-the-art infrastructure. With twin steerable jets, thrust can be vectored for tight, low-speed handling in concert with thrusters, while booster jets come online for when the owners want to have a little bit more fun and go into sprint mode. The jets are reportedly built by Wärtsilä's axial flow modular family, and they are driven by 2 gas turbines as well as MTU diesels, which are also CODAG setup. Of course, you cannot expect Lürssen to publicize every part number. If you were to dig a bit deeper in open literature, you'd be able to find them for yourself. So the facts we're preaching here are all based on research done from our side. In order for you to have a better understanding of the placement of Azzam's propulsion layout, just have a look at this picture. The orange circles represent the gas turbines, the green ones are the diesel engines, and the yellow block is the combining gearbox, or the CODAG system. Furthermore, you have cyan rectangles, which are the steerable water jets for maneuvering and thrust, and the sky blue rectangles are the booster water jets used for sprint power. The arrows are showing the power flow. Diesels and turbines feed through the combining gearboxes to the 4 jets at the stern. Don't worry, I haven't forgotten about one of the biggest challenges that this vessel has, combining turbines and diesels onto water jets. This is the part where we'll talk about the transmission and integration of the Azzam, which starts with combining gearboxes and clutches to bring each prime mover online without shock loads. Furthermore, the intake design is key to avoid flow separation and air ingestion in waves, while the exhaust and thermal management are used for turbines. Extensive acoustic isolation is added for the diesel line shafts and jet tunnels, standard naval architecture solutions for CODAG jet yachts of this scale. And if you wondered how the CODAG machinery feeds through gearboxes into water jets, let's have a look at this side cutaway schematic of Azzam's propulsion setup. The orange circles are the gas turbines. They sit higher in the machinery space, vented through dark gray exhaust stacks leading above the superstructure. The green circle is the diesel engine that sits lower, feeding into the yellow gearbox. The sky blue rectangles under the hull are the water jet intakes drawing water up into the jet pumps, whereas the cyan steerable water jets combined with the booster ones discharge aft at the stern. Exhaust stacks and intakes are positioned to minimize draft impact and maintain stealth and comfort. The key achievement here is to have a vessel with that scale to reach speeds of over 30 knots. It is verified by Lürssen, and multiple technical sources report that speeds over 32 up to 34 knots have been reached on sea trials depending on the load and the state of the yacht. Again, we have to mention the genius combination of turbines and booster jets, primarily used for this regime. We do not have verifiable range figures regarding the cruise in range, but the CODAG systems that the yacht cruises on diesel are at far lower SFOSC than turbines. This keeps the turbines in the best possible shape, further proving how big of an engineering masterpiece Azam is. The NVH standards, or noise, vibrations, and harness, are another integral piece of this project. Reaching it with a vessel of 180 meters that is capable of running at speeds of 30 knots while meeting the luxurious NVH standards involved key strategies. The jet selection is one of them. Water jets transmit fewer low-frequency pressure pulses to the hull than large open props. Raft-mounted machinery and resilient foundations, which are especially used for the diesels and the gearboxes, help this cause as well. On top of that, Azam has structural damping, usually made from constrained layer or tuned mass elements near jet tunnels and machinery spaces. Cabin isolation packages have been built in order to hit the no perceptible vibration targets, all of them noted in the open profiles of the yacht. But we're just getting started with this beauty. Let's talk a bit about the propulsion and the drivetrain. The architecture is a combination of a CODAG, an abbreviation for combined diesel and gas and water jets. It's the perfect way of reaching the speeds it does. 2 gas turbines and 2 diesel engines are driving 4 water jets. The jet setup is made up of 2 steerable water jets for thrust vectoring and 2 booster jets, who, keep in mind, are non-steerable and are helping add straight-line thrust at speed. If you combine all of these factors and calculate the horsepower of Azzam, you'd reach extraordinary numbers, 94,000 horsepower, or 70 megawatts. These are primarily reached by the twin MTU 20V 8000M91 engines, each reaching 12,205 horsepower. That's the primary thing that enables it to reach speeds over 30 knots. And in the engineering world, there has been a big discussion as to why Lürssen decided to go with water jets and not propellers. There are a couple of logical reasons behind this decision, starting with the cavitation control and efficiency at high Froude numbers. The speed that the vessel can reach was always going to require thinking outside the box from its manufacturer. So at speeds around 30 knots, large conventional propellers would cavitate heavily. Therefore, axial flow modular water jets are the perfect choice for keeping the efficiency of the superyacht at a top-notch level while also maintaining very low vibrations and noise. There are a lot of other aspects that we need to talk about regarding the Azzam, including the HVAC system. The HVAC, or heating, ventilation, and air conditioning, is a system designed to regulate the temperature, humidity, and air quality within a certain space. And let's keep in mind that this giant is 180 meters long, so the challenge of feeding the HVAC system, especially in warmer climates, is kind of a big thing. So the Azzam runs megawatt-class electrical plants in order to keep itself up to the task, and on CODAG yachts, the electrical plant is independent of the propulsion turbines, with load shedding and bus tie logic for redundancy. You didn't think we forgot about the stability and the motion control, did you? Azzam employs at-anchor stabilization and active fin roll systems underway. The long waterline length helps in the process of reducing pitch in moderate seas, and the aluminum superstructure helps save tons of weight aloft for GM margins without having to sacrifice amenities across multiple decks. As I mentioned earlier in this video, the yacht was built in 3 years, an extremely short time for such a heavy project. Thanks to the parallel build of major blocks and superstructure models, early freezing of weight and systems envelopes in order to avoid growth, as well as close interaction and collaboration between Nauta and Lürssen to lock the propulsion and intake geometry early, have all helped the cause. Let's have a proper look at the enhanced system of how Azam keeps itself stable and afloat. The red fins that you're looking at are active stabilization fins that reduce roll while underway. The purple discs on your left are at-anchor stabilizers, and they're practically zero-speed fins to cut roll at rest. The orange, green, yellow, and cyan sky blue are the CODAG plus water jet propulsion system that we discussed before, while the dark gray stacks are the gas turbine exhaust routing upwards. The sky blue underhull boxes are the water jet intakes, showing the full hydrodynamic control package. Not a lot is known about the interior of Azzam. What we do know so far is that the vessel is capable of accommodating up to 36 guests in 18 suites and has space for 80 crew members. The fuel capacity is 1 million liters of fuel, but again, the project itself pushed the boundaries of what was believed to be impossible. It's a rare convergence of very high length and a very shallow draft. As if this wasn't enough, the high speeds that it reaches are a reminder that once great minds come as one, nothing is impossible. The significance of the project lies in pushing the CODAG plus multi-jet integration on a 180-meter displacement hull, as well as demonstrating NVH and thermal management solutions that keep a turbine-capable platform quiet and comfortable. The yard-level concurrency achieved with Azzam delivered a unique project, a giga yacht on quite a tight schedule, and with validating the shallow draft big yacht hydrodynamics and structure without having to compromise range or sea keeping in moderate conditions, Azzam stands in a league of its own.